go to problem 62, the ideal gas law. So in this problem, we're trying to figure out the molar mass of the gas. Let's go ahead and read the problem. A 120 gram sample of a gas is in a 52.2 liter container. The pressure and temperature of the gas are 1.25 atmospheres and 298 Kelvin. Determine the molar mass of the gas. So we're going to do this a couple different ways. The first way we're going to do it, let's go and write down everything that I have here. I've got the mass equal to 120 grams. I've got a volume of 52.2 liters. The pressure and temperature, the pressure is 1.25 atmospheres. The temperature is 298 Kelvin. And then we always know R, that's 0.0821. So I'm going to do this a couple different ways. The first way is I'm going to use the derived equation. So I'm going to say PV is equal to nRT, and then I'm going to plug in for N that N is equal to grams divided by molar mass. Okay, and we derive that in the lecture video. So I'm going to plug that back in. I'm going to get PV is equal to GRT over molar mass. I'm solving for molar mass, so I'm going to get it out of the bottom. So there we go. And now it's just a matter of plugging and chugging. So molar mass is equal to my grams, which is 120, times R, times T, which in this case is 298 Kelvin. And then that's all over what pressure times volume. So pressure is 1.25. The volume is 52.2 liters. So let's see. Liters cancels out, atmospheres cancels out, Kelvin cancels out. I end up with grams divided by moles, which is molar mass, so I'm in good shape. So I got 120 times 0.0821 times 298. And then that whole thing divided by 1.25 times 52.2. So we get a molar mass, and looks like I should have, this has 2 sig figs, so I'm going to go with 2 sig figs here. Molar mass equal to 45 grams per mole. So that's one way you could do it. The other way you could do it is just use PV equals nRT, solve for moles, and then take your grams divided by your moles. Let me show you. So this time I'm going to solve for moles because I know that molar mass is equal to grams divided by moles. Here's the grams, so if I can find the moles, I can find the molar mass. Right? So pressure times volume all over R times T, 298 Kelvin. That's equal to moles. So I get a value of, for my moles, 2.667, and I'm going to leave all of those because this isn't my final answer. So then I'm going to plug that over here. So molar mass is equal to 120 grams divided by 2.667 moles. And I get an answer of 45. Same answer, which it should be. But one thing that I want you to keep in mind, anytime you're trying to calculate molar mass, you need to know 2 things. You need to know how many grams and how many moles you have. Okay, as long as you know how many grams and how many moles you have, you can always calculate molar mass.